Welcome, and thank you for joining Digi International today for our feature presentation, Cutting the Cable, a guide to RF integration, which will take you through many of the basics of RF technologies for IoT applications and cover some of the considerations to be made in making the choice of which solution should be employed in your design. Today's presenters are myself, Ron Singh, Director of Distribution Sales for Digi International in Europe, Middle East and Africa, Alfonso Martin Ray, Field Apps Engineer for RF and Embedded Products at Digi International, and Martin Schutholbein, Field Application Engineer Manager for RF and Embedded Products at Digi International Europe. For those of you who don't know too much about Digi International, we are a 30-plus-year-old US-based company centered in Minneapolis, Minnesota, specializing in products and solutions for customers seeking solutions for the Internet of Things and their applications. Our offerings fall broadly into three key segments. First of all, what we call our box products, a range of cellular LTE routers and gateways and infrastructure management solutions, including USB over IP and serial to Ethernet connectivity. Our OEM solution offerings, a wide range of embedded system-on modules with Ethernet and wireless connectivity enabled, and the world-renowned Digi XBee modules, a family of footprint-compatible wireless devices covering sub-gigahertz, 2.4 gigahertz, and cellular technologies. Now, overarching all of our hardware products is our software offering, including DRM, our remote management platform, and XBee Tools, a suite of applications available for simplifying system design cycle, deployment, and management of wireless devices. And finally, core to all of our products is TrustFence, our over-the-air upgradable security framework. The agenda for today's presentation will include, as mentioned previously, a session on RF basics, a guide to selecting and integrating the right RF for your design, given the constraints of bandwidth and distance to cover. An overview of the Digi XBee product portfolio, and a broad overview of the Digi XBee Tools, our suite of software applications which are designed to accelerate your design, deployment, and management of your network. So I'll now pass you over to Alfonso, who will continue with the rest of the presentation. Thank you, Alfonso.
Thank you, Ron. So the agenda for today, in order to cover these RF basics, is to show you the components in a basic communication system, and after that we will try to show you some of the concepts and parameters which will be involved on that. And later on we will show you some of the protocols that Digi can offer. So let's start. So in a basic communication system, so you will have a transmitter and receiver, and in the middle two antennas, and also the air or the environment where the electromagnetic wave needs to travel through. So the next question that everybody is wonder, how can I maximize the range, or how can I maximize the coverage? So the first thing that you can do is increase the power in the transmitter, so you can speak louder. Also, you can try to increase the antenna gain in both sides, but normally this is limited by the government. so you cannot touch as much as you can those parameters. A nice trick that you can use is to try to increase the sensitivity on the receiver, and this is a nice value that you should compare when you are looking for radio devices. Of course, you can clear as much as possible the environment, and in order to understand how to do that, we will show you the difference between the visual or the linear line of sight, which is not the same for a RF or the radio line of sight. In order to understand what is the RF line of sight, you might want to have a look to the Fresnel zone. Okay, so the Fresnel zone is how the electromagnetic waves are traveling over the air. So they are using a shape of Zeppelin or rugby ball, so the electromagnetic waves are not traveling like a laser. The size of the Fresnel depends on the frequency and the distance between the transmitter and receiver. If obstacles are inside of the Fresnel zone, your link quality will be lower than 100%. If the antennas are on the ground or close to the ground, half of the Fresnel zone is in the ground, reducing your link quality a lot. To increase range, try to clear the Fresnel as much as possible, for example by raising the antennas as high as possible. The range for an RF product documented in the datasheet is measured with a Fresnel zone that is completely free. The radius of the Fresnel zone is the optimal antenna height without taking the curvature of the Earth into account. For long-range product, you have to raise the antennas even higher because of that. Here are some examples. For the 868 MHz base product available in Europe, the maximum range is 14 kilometers. So you can see the antenna height for a free Fresnel zone is around 37 meters to achieve the maximum range. For the 2.4 GHz base product available worldwide, you need already 3 meters antenna height for a free Fresnel zone in a range of 300 meters. What are the differences between 868 MHz and 2.4 GHz? So the advantages of the sub-gigahertz bands is at the same level of power you will achieve longer distances, you will have better wall penetration. Today, at least, this band is a less crowded space, and in Europe, the government limitations are less strict than the 2.4 GHz. So in Europe is 25 milliwatts. The trade-off is obviously in the sub-gigahertz band you will have a smaller data rate, and for example ZigBee is only available in 2.4 GHz, and in particular with 868 MHz this band is only available in Europe. A convenient way to measure transmit power and receiver sensitivity is by using dBms as a unit, which stands for decibels referenced to 1 milliwatt. It used a logarithm scale, which is a way to compress the measurements and values. This allows you to express large and small values in a short form. So there are few rules of thumb for the relationship between power and range. 3 dBm increase double the power. 6 dBms increase doubles the range outdoor with the free Fresnel zone, and the last one is 12 dBms increase doubles the range indoors. So some examples about the parameters. So minus 10 dBm is the typical power that is used in your Wi-Fi network, and the XBee3 modules working in 2.4 GHz are normally below 10 dBm or below 10 milliwatts. So in order to convert dBms to milliwatts, you can use this hint. So the 10th in the dBms value shows you how many zeros you need to add in the milliwatt value in the linear scale. As mentioned, 2.4 GHz is available worldwide to be used by short-range communication devices. For longer-range RF communication, Digi support 868 MHz in Europe and 900 MHz in Americas, Australia, and some parts of Asia. Digi is also supporting cellular technologies like, for example, 3G, Cat1, LTE-M, and narrowband IoT, depending on where it's deployed. So now let's talk about protocols, and I will start with the 802.50.4, which defines point-to-point and point-to-multipoint communication. The idea with this protocol is the radios can only talk with the guys which are directly connected to you, or talking about RF world, the guys which I can reach directly with my signal. So for example, node A can only communicate directly with the devices that are on the RF coverage. So for example, in this slide, you can see that A can only talk with E, D, and B, okay, because the others are far away. So if node A would like to talk with some of the nodes which are out of direct RF range, you need to implement by yourself the retransmission mechanisms, because 802.50.4 is not supporting any kind of routing or retransmission. Because of this, using this protocol will limit the distance that you can cover with your network. And also, you might have a single point of failure. The benefits of 802.50.4 are: it is simple, in general faster than mesh networks, and it also offers very low latency, which is often required for remote control applications. So to summarize, 802.50.4 can support point-to-point, point-to-multipoint, so you can implement a star topology. So it relies on carrier sense multiple access collision avoidance protocol, and also it's implementing some mechanisms to retransmit the packages if errors occur. Again, the benefits: high speed, low latency, and very easy to use. Of course, you can send broadcast packages, which means one guy is speaking and all the other nodes in the network are just listening. But also you can send unicast package, which means that one packet or one communication will be from one node to another node. Let's talk about mesh networking, and we will show you the difference compared with the 802.50.4. The mesh networking is adding more layers into the stack, and the idea is the network can route the data by itself. Obviously, once you can reach a node which is not directly accessible by you, you can increase the range of coverage of your network. The network is going to take care about itself. So it's going to update the routing tables, and also it's going to repair itself because the network will implement an algorithm in order to have the routes always available. Digi is offering two mesh network alternatives, which are ZigBee and DigiMesh. The idea is whatever node can talk with any other node in the network, and the network will handle the packet in order to reach the destination. So, one example, if A would like to talk with N, the nodes in the middle will retransmit the packet in order to reach the destination. If for whatever reason, whatever of the nodes is not aware about the final destination, the network itself will look for the right route. Obviously, the network can also have redundant routes, so this will improve the reliability of the network. So for example, if some nodes for whatever reason has disappeared, then automatically the network will discover a new route in order to reach the destination. The trade-off is that in order to implement and execute all this process, the network will behave slower than the 802.50.4 that we have seen before. So to summarize what mesh networking is offering to you, so you can cover a large area, you can create up to 1000 nodes per network, you can repair easily, or even the mesh network will do it for you if you have some problems with the communication between the nodes. The network is going to maintain itself, and the idea is the nodes are not moving around, okay, because otherwise you will need to force to the network to update more often the routing tables. Looking at the security, so we can offer 128-bit encryption for ZigBee and 802.50.4 and 256 encryption mechanisms for DigiMesh. Let's have a look to ZigBee, which is one of the mesh network options that Digi can offer. So in ZigBee, you can have three types of nodes. So the coordinator, which is the only node which can create a network, and once the network is created, coordinator can also change on the fly one of the important parameters, and once this is done, the coordinator will behave as a standard router. The routers, these are the backbone of the ZigBee network, and those are the guys who are retransmitting or routing all the data in order to reach every node in the network. Coordinators and routers obviously needs to be mains powered. And the third type of node is the end node, which could be battery powered, and those end nodes has a parent-child relationship with routers. And the number that you need to be aware is one router can support up to 20 end nodes. In order to understand how ZigBee is working together with 802.50.4, so it's relying completely on it. So on top of the standard 802.50.4 features, so ZigBee is providing you the mesh networking functionality. The three types of node that we have seen, and again the benefits is you can create a larger coverage and large number of nodes network, but also the network is going to take care about itself. Now let's have a look to DigiMesh. In this case, DigiMesh has only one type of node, so everybody is in the same level. So all the devices are routers, and you can replace them wherever you want. The additional benefit with the DigiMesh is all the devices can be battery powered, so everybody can go to sleep. Again, how DigiMesh is working together with 802.50.4, so on top of that. And again, the benefit of the DigiMesh network is that you can put all the network to be in a synchronized sleep state. So how this is working? The idea is DigiMesh network is managing automatically itself the synchronization in order to allow to everybody to wake up and to sleep simultaneously, so all the traffic and all the data interchange will happen in these wake up slots. This is only available in DigiMesh. So here is a summary with the main features of both mesh technologies. So ZigBee is an interoperable open standard. It defines multiple node types, including mains power routers and end devices. Also, it works well in concentrator networks where all the devices talk to a gateway and vice versa. And the typical maximum amount of nodes per network is between 500 to 800. DigiMesh is a proprietary protocol developed by Digi. It is supported on sub-gigahertz in addition to the 2.4 GHz band, and it works well in networks that require frequent broadcast. The maximum amount of nodes per network is around 1000, but recall that the maximum amount of nodes in an RF network depends on the traffic generated by the application. We have created a decision checklist for you to be able to find out if ZigBee is the right protocol for your application. We also created a checklist for DigiMesh to be able to find out if DigiMesh fits better in your use case. In addition to short range and mesh technologies, Digi also offers cellular for Internet of Things, IoT. LPWAN stands for Low Power Wide Area Network, and it covers several long-range technologies with reduced bandwidth and low power. Digi provides RF products supporting several cellular technologies such as 3G, Cat1, LTE, and narrowband IoT. LTE IoT is a branch of the general LTE technology focusing on simple radius, low bandwidth, low power, and of course, low cost. The benefits of using a cellular technology such as LTE are: the product can leverage standards that are implemented globally, using a mature ecosystem of carriers, operators, and product manufacturers. Products can use existing infrastructure such as cell towers. There is no gateway or other devices required to connect to Internet. The technology offers fast time to market and low cost of ownership. LTE IoT technology is scalable in regards to bandwidth and to other features. It offers deeper coverage and excellent building penetration, which allows you to mix indoor and outdoor devices. Here's a comparison table for the three main cellular IoT technologies Digi supports. A few items to compare could be data rate, firmware over-the-air capability, the power consumption, range and wall penetration, and last but not least, the cost. Now, I will hand over to Martin. Thank you.
Thanks, Alfonso. In this part of the session, I will explain the Digi XBee product offering briefly and discuss the various XBee tools offered by Digi, which are used in different product and development lifecycle phases and which reduce the complexity of the tasks required to develop, build, deploy, and manage RF devices. XBee is a Digi brand name. It is the name of a product family of RF communication modules, gateways, and tools supporting various frequencies, protocols, and topologies. The modules come in multiple hardware variants, which share a common form factor and are pin compatible and software compatible to make it very easy to switch from one technology to another or to migrate to a more recent variant of a module that provides new functionality. In addition, the modules come with global certifications, which greatly reduces the certification effort creating a final end product using an XBee module. As with any other Digi product, a key focus of the XBee product family is to make the development and deployment as easy as possible, to reduce risks for the customer and decrease time to market. We provide various options to utilize and program the module, all of which are simple and easy to use. This allows developers to connect sensors or actuators directly to the module and write applications using simple APIs or the MicroPython programming language. In addition to the software stack on the module itself, we provide libraries that allow developers to create applications using the module as communication devices in various other use cases. For example, when the module is connected to a microcontroller, or when it is embedded into a more sophisticated device, such as a custom RF gateway. To simplify and accelerate the development, manufacturing, and deployment processes, we provide a vast amount of software and hardware tools to be used by the different type of people contributing to the product lifecycle, such as developers, manufacturing engineers, and service personnel in the field. In general, the Digi XBee product offering can be divided into three different categories: short range, long range, and cellular. Remember that even across those categories, the modules are pin and software compatible. Short range modules operate on 2.4 GHz and support protocols such as 802.15.4 for simple and fast, low latency point-to-point and point-to-multipoint communication, as well as two mesh technologies, ZigBee and DigiMesh. Both are used to create intelligent self-routing and self-healing mesh networks. ZigBee is an open interoperable standard. DigiMesh, which is a proprietary protocol developed by Digi, supports completely battery-powered mesh networks, as we heard from Alfonso earlier. The long-range products are based on 868 MHz for Europe, Africa, and Middle East, and 900 MHz mainly for the US, some parts of Asia and Australia. Long range in this case means 1 to 3 kilometers on 868 MHz outdoors in practical conditions, and typically up to 40 kilometers using 900 MHz. As you can see, the different regulations regarding maximum output power across the world have a significant impact here. In general, a lower frequency has the benefit of providing better range and better material penetration, which means the long-range products are also often used in indoor applications. On the other hand, higher frequency provides more bandwidth. So mesh technologies typically require higher bandwidths, and Digi has optimized DigiMesh so it can run on sub-gigahertz in addition to 2.4 gigahertz. Apart from DigiMesh, a point-to-multipoint setup is supported as well on the long-range products. Last but not least, we offer XBee modules supporting multiple cellular technologies such as 3G, LTE Cat 1, LTE-M, and NB-IoT. 3 compatible hardware variants are available: a micro module, also called MMT, a through-hole module, which has pins attached to it, and a larger SMT module for backwards compatibility to legacy XBee modules. The XBee Cellular is a variant of the through-hole form factor with additional UFL connector and a SIM card slot. All of these offer various antenna options, such as PCB or chip antennas, UFL, SMA, and RF PET connectors, depending on the hardware variant. Security is a very important but also complex topic. Digi is providing a security framework called TrustFence. TrustFence is a Digi brand name. This framework provides several fully implemented security features for the XBee module. For example, secure boot makes sure only authorized digitally signed firmware is running on the module. Secure storage encrypts the local file system. And of course, secure connections authenticates and encrypts the actual data communication. TrustFence is added value provided by Digi to allow our customers to make their IoT devices more secure without the need of spending significant time to implement these features. The footprint, pinout, and software compatibility between XBee modules allows developers to create future-proof solutions. For example, it is easy to migrate to a newer module that provides additional features. But it also allows to upgrade to newer technology without changing carrier boards or software implementations. You can see this as an insurance for your investment. We typically do not have this ability on chip designs or other solutions. This is the major benefit of using a Digi module. Digi's products are on the market for at least 10 years, often longer. Product longevity is a key philosophy of Digi. Let's have a look at the complete XBee ecosystem. XBee RF modules are the foundation of this complete IoT networking solutions. For products that do not have an IP stack included directly, we provide off-the-shelf programmable gateways that provide a bridge between RF and IP for remote connectivity, if it's required. IP interfaces supported are cellular, Ethernet, and Wi-Fi. Different variants of gateways are available for different use cases. XBee cellular modules have an IP stack included and can connect directly to the internet. Customers can use or implement available or custom protocols for server, backend, or cloud communication. We provide examples and instructions to connect to the major cloud providers, such as AWS or Azure. In addition, customers can utilize Digi's cloud-based device management and communication platform, Digi Remote Manager. Digi also offers professional services for customers in need of assistance with hardware or software development, certifications, or other RF-related topics. And finally, Digi is offering a vast amount of hardware and software tools to accelerate and simplify tasks in all the different product and development lifecycle phases, which include the development of the product, including hardware and software design, building or manufacturing the final end product, deployment, commissioning, and mass rollout of the product in the field, ongoing management, maintenance, and communication with devices in the field. Note that all the software tools provided by Digi are completely free of charge. We provide a powerful software stack that runs on the module. In addition to a common AT command and transparent data mode, Digi provides a higher level, simple but powerful API communication mode, which allows developers to utilize all the features of the protocols and the module itself, such as acknowledgement and status messages, diagnostics, network discovery, remote configuration and firmware updates, and remote access of hardware interfaces such as analog I/O or digital I/O, and more. This high level of integration is unique in the market, enabling fast development of reliable applications. Customers that want to connect the module to an external device, such as a microcontroller or embedded system, can leverage existing libraries available for different programming languages to implement their applications. On the other hand, applications running on the XBee module directly can be implemented using the MicroPython programming language, which allows you to add edge intelligence to your products. An external microcontroller is not required in this case. Several examples for standard or custom protocols for communication to sensors and actuators connected directly to the module to demonstrate the use of the Bluetooth Low Energy features on the module, and many more are available. For the development of these MicroPython applications, we provide a plugin for the popular PyCharm IDE, which is used by many Python developers. It automatically detects connected XBee modules. You can deploy or debug applications with one mouse click, which includes standard debugging tools such as setting breakpoints, stepping through the code, and so on. It includes wizards to get started with each XBee product that is supported, and it includes a huge number of samples for different use cases. XCTU is the configuration and test utility for XBee products. It allows configuration and firmware updates of modules connected to a PC and remote devices in the network. It comes with a graphical network view, providing a logical view of the network, including the connection quality of RF links. It includes several tools to test and analyze API communication. And one of the most popular tools is the built-in range test, which can be used for evaluation and site surveys. You only need a module powered by a PC or a USB power plug and another module connected to a laptop, for example. And when you start the range test, you can freely move around with the laptop and the connected module and observe real-time updates of signal strength and packet delivery rates depending on range and RF conditions. XCTU also includes a serial console to test data communication and even a spectrum analyzer and a throughput measurement tool. It is really the Swiss Army knife for developing with XBee modules. For app development, we provide a software development kit called XBee Mobile SDK that allows developers to create mobile applications communicating with the XBee over Bluetooth. For example, an end-user application that visualizes sensor data on a mobile device from a sensor connected to the XBee. This SDK provides authentication, encryption, and communication APIs and is available for multiple platforms such as Xamarin for iOS and Android and Java. Code examples and documentation are included as well. Digi also provides hardware tools that can be used in the evaluation and development of an XBee product. For example, our development boards are available for all XBee form factors, and the most recent board includes an onboard temperature and humidity sensor and connectors to add third-party sensors easily. This allows you to create full end-to-end IoT proof of concepts in a very short time frame. In addition, there's an extension header on the board, which allows you to add custom add-on boards for other functionality. As an example and reference, we have developed a GPS daughter board providing location data for applications. It comes with complete design files and MicroPython source code to be run on an XBee module. The next product lifecycle I'd like to discuss is the manufacturing of final end products, which in most cases require the XBee modules in the design to be programmed or configured. To support this, Digi has developed the XBee Multi-Programmer. It is a hardware board that allows concurrent programming of up to 6 XBee modules, including module or cellular modem firmware update, and the deployment of configuration settings and MicroPython code. Multiple programmers can be daisy-chained to increase the number of modules to be programmed simultaneously. And it comes with software to run on a PC that shows progress and status of each programming process. You can also export programming reports for your quality department. For deployment of products in the field, Digi provides a software tool called XBee Network Assistant. Remember that the focus of our XCTU tool is the configuration, update, and testing of one or a few modules in the lab or office. The focus of the XBee Network Assistant is the mass rollout and commissioning of multiple devices in installations. Instead of using a logical map, XBee Network Assistant uses a physical map, for example, a floor plan or a Google Maps layer, and it includes visualizations of network routes and link quality. In addition, Digi provides the XBee3 USB stick, a XBee node in a USB stick form factor, which can be connected to PCs directly without the need of development boards. This can be useful for workers responsible for commissioning or maintenance on site. The XBee Mobile SDK we discussed earlier can also be used to create custom commissioning and deployment applications that can run on mobile devices. Digi provides a full app that can be downloaded from Google Play Store or Apple App Store that demonstrates this use case. We provide the source code of this application as a starting point for commissioning and deployment tools implemented by customers. When we look at the Bluetooth capability available on the XBee3 modules in general, it is worthwhile to mention a few features we support specifically and additions Digi made. First, Digi has implemented an additional security framework that works on top of the normal Bluetooth communication. This framework is based on the Secure Remote Password (SRP) protocol and is improving the security for Bluetooth connectivity significantly. Second, the module supports Bluetooth Low Energy beaconing, custom advertisements, and the ability to receive data from external Bluetooth Low Energy devices such as sensors. To conclude my introduction of the most relevant tools, let's talk about remote connectivity for device management and data communication. Digi offers a cloud-based management and communication platform called Digi Remote Manager. It works with any Digi product and provides remote management and application data communication capabilities. Management features include automatic secure firmware updates, configuration settings, status and device health monitoring, alarms, and much more, either for single devices or groups of devices. Digi Remote Manager also offers the capability to easily connect end-user applications with multiple devices in the field to send and receive application data. With Digi Remote Manager, you have full access to the XBee modules, not just cellular, but also modules connected through a gateway, for example, ZigBee modules. This enables you to access data from your end nodes with other applications, such as web or cloud applications using open APIs provided by the platform. If you plan to develop a custom RF gateway or a more sophisticated concentrator device, we recommend to combine a Digi Connect Core product and a Digi XBee module. Digi offers embedded system on modules based on NXP's IMX application processors and single board computers populated with these SOMs. Those single board computers are ready-made boards which can be used without additional hardware development. The Digi SOMs on those SBCs have Wi-Fi and Bluetooth already integrated. By adding a XBee module, you can extend the wireless capabilities with, for example, 2.4 GHz ZigBee, sub-gigahertz, or cellular. The Connect Core SBCs are equipped with an XBee socket, and the operating systems running on the DigiSoms, Yocto Linux and Android, contain libraries and tools supporting XBee modules for easy software development. This is the easiest way to create a custom RF gateway. Here are some links to a few topics we discussed in this presentation, including links to the XBee portal, our documentation, example projects, and other useful resources. To get started with an XBee product, we offer various development kits which are coming with modules, dev boards, antennas, and everything else required to get up and running in a few minutes. We listed the part numbers for the short-range XBee ZigBee Mesh Kit and the XBee Cellular Dev Kit as examples. Thank you very much for your attention, and goodbye.